Hello, students. Today we're going to continue talking about water. I'm going to hopefully answer some of the questions that you were asking about yesterday in your Schoology quiz. So we'll go ahead and get started. Why should we care about water? When we look at water here in Minnesota, and as a Minnesotan, we think, what's the big deal? We've got water everywhere. There's water in our 10,000 lakes that we have. We've got major rivers. We don't experience major drought like California. We are very, very, very fortunate here in the state of Minnesota. We don't have to worry about our water. And because we're in the Midwest, we're actually the headwaters of several major rivers. We are the headwaters of the Mississippi River that starts in Lake Itasca in Minnesota, and we are the headwater of the Red River, which actually flows north up into Canada, and we're the headwater of the Minnesota River, which runs, I'll just kind of highlight that over here, that runs from the west part of our state down and then kind of makes a V and heads back up towards St. Paul, where it joins up with the Mississippi River. So we are the beginning. The headwater means it's the beginning of the river. And so we don't have to worry about other people's pollutants. We are the start of these major rivers. So we already have relatively clean water. And again, we have abundant water. There's also a lot of groundwater. We have a lot of groundwater, meaning the aquifers underground, under the surface, where we can then have wells that kind of pump water up from underground to help supply our communities with water. So in the state of Minnesota, again, we get to take this for granted. Not that we should take it for granted, but we do because it's plentiful and we don't have to worry about it. And it's pretty relatively clean compared to other parts of the world. So does that mean we shouldn't care about it? No, it just means that we need to make sure that we're educating ourselves and learning more about it so that we can help others hopefully get better access to clean, safe drinking water. This map I actually took from when I was in a master's program, and I thought it was just really important to see globally how again, not everyone is as fortunate as we are here in the state of Minnesota. So this is looking at exploited water resources. So the map is taking into account the environmental water needs. And remember, every living thing needs water. So all of our crops that we plant, it needs water. All living organisms need water. And again, there are certain parts of the world that simply don't have access to large amounts of water. They're just because of the geography or whatever location, it's not accessible. And so you can see these areas that are like overexploited. A few years ago, I'm just picking one place on the map here, in South Africa, there was a water crisis in, I'm blanking on the name of the town, Cape Town, and they had a water crisis, and they were going to have to start rationing water out to the people in their community because they were running out of water as a resource for drinking. That's not okay. Like that's water is a basic right, a basic need for all living things. And so again, just wanting to talk about the importance of water, even though we don't have to worry too much about it here in the state of Minnesota. So thinking about our drinking water, there's kind of this, we know about the water cycle outside and the natural water cycle, the evaporation, the condensation, the precipitation, and so on and so forth, constantly cycling because of the energy from the sun. But there's also our drinking water cycle. So where do we get our water from? And some of you were asking this question in the Schoology quiz. So think about starting at the source. And later we'll talk about source water protection. We have to protect the source of the water. If you start with polluted or contaminated water, well, that's not a good thing. Then you have to make sure you treat it more. So starting with the source, wherever we get our water. The city of Edina, most of the water in Edina comes from an aquifer underground. But I think it's the Morningside area of Edina, they get their water from surface water in Minneapolis, which is really, I think, coming from the Mississippi River. So that is the source of the water is surface water, meaning it's more exposed to the activities of humans, so it's more exposed to pollutants, litter, any kind of contaminants from wildlife. Animals go to the bathroom outside, and any of that can wash down into the water. So starts with the source. So then we have some kind of a pump, and we take that water from the source and we bring it to a water treatment plant. In Edina, again, there's 4 different water treatment plants. Fun fact, one of them is actually underground, and I believe it's under the Lunds and Byerly's. I'm not as familiar with all the streets in Edina, but off Vernon, I think it is. So there's a water treatment facility underground there, and this is part of your public works. If you ever have an opportunity to tour a water treatment facility, I highly recommend it. It's super interesting. You can learn a lot. There's usually the public works people are more than happy to teach young people, especially. If you can take a tour, once COVID-19 is over, then go out and explore and make a phone call. See if you can tour the plant. It's really quite interesting to see how they take water from the water source. And when I toured a plant once, I saw a fish floating in one of these giant vats. It's like, well, where did that come from? And why is that part of my drinking water? But they clean it, they treat it, they filter it, and then they add things to it to help make sure that it tastes okay, that the pH is appropriate, that the water hardness, you've probably heard of like hard water or soft water. You have a water softener at home. So they have to treat the water. They have to treat it with chemicals like chlorine to help kill any pathogens or bacteria. They add fluoride to it to help strengthen your teeth. And so there are definitely some things that are being added to the water at the water treatment plant. But again, it's making sure that it is safe for distribution and that it's clean to be distributed to your homes. So then it goes into the storage, usually the water towers nearby. And as you can see in the picture, then there's those blue lines, the blue pipes that would be coming from the water storage system into your homes. So then that's where you can turn on your faucet and you have clean water coming out of the faucet. Now, those pipes that are carrying the water, those are also really important for us to consider. And we'll talk more about that in terms of the Flint, Michigan water crisis. But it's important to maintain the infrastructure, the distribution pipes of our water treatment facilities, as well as the distribution system and getting it to your houses. And then when we're done with the water, when after doing dishes or taking a shower or flushing water down the drain or the toilet, doing laundry, all of that water that we then use that goes down our drain, it goes into a wastewater treatment facility. So all of these red lines then, again, coming out of our houses, we've got these pipes that will then take our wastewater in the sewer lines over to a wastewater treatment facility. So that's where it will then remove any of our waste. They can try to remove some of the chemicals that might be in our water, like detergents, or obviously solid waste material, things like that. So after it's clean and relatively clean and filtered out, then they can discharge it back into a body of water or into a wetland. I believe that the city of Edina actually then takes that discharge water and puts it into the Mississippi River. So that is where that ends up. So that's again, drinking water, or like our human use water cycle. Thinking about there are 3 main threats, or 3 kind of categories of threats to our safe drinking water. Our society, just our communities, the people, the areas that we live in, we use a lot of water and we impact a lot of water just by living and by feeding our people. So these 2 pictures are kind of like the big extreme ways that we can really contaminate a water source. We could have factories that are dumping chemicals or waste materials into a body of water. And again, this one is kind of a big dramatic, like, oh my gosh, that's a pipe dumping what looks or appears to be really gross, disgusting water into a basic water system. that's obviously not a great thing, but it does happen. And it's not necessarily like, here, let's just empty this pipe into the water system. But sometimes we could have cracks or leaks in our pipes that could then seep into a local water system. So it's not necessarily like an intentional dumping of contaminated water into a water source, but it could be that a water pipe, as it's carrying it somewhere else, is actually broken or it cracked, and then it seeps into a water system. So that's one way that we can then contaminate or cause our water source to have pollutants that could cause harm to us. Another way is agricultural and residential runoff. So in Minnesota, we have a lot of farm fields and we feed a lot of people, and it's really great. But as you know, we also have to treat our fields. And when we're using excess chemicals, if it's if the fertilizers are not being used by the plant, which we know fertilizers can be great food for plants and it can help promote growth so that we have a better crop yield, that's all great. But if there's excess fertilizers or excess pesticides that are not doing the job that they're intended to do, which is to help promote growth of crops or to get rid of a pest, any of that excess chemical is potentially able to then go into our water systems, our surface water, into the local streams, if from a ditch down into the stream or into a river or into a lake. And so that can contaminate our water source. If there's a city or a community that then uses that water for drinking water, they could potentially have some harmful impacts. And even just the improper disposal of household products. So if you're dumping chemicals down the drain, or sometimes people will throw prescription medicines down the toilet, they'll flush it down the toilet. Our water treatment facilities are not necessarily going to be filtering out every type of chemical that would be in those medications. And so those medications are now ending up in our water systems. And that can have an impact on the wildlife. So if we're dumping water into a lake or into a stream and it hasn't been treated for those chemicals because there's so few of them, but if several people are doing it, like birth control pills have been impacting wildlife. We've seen some enlarged fish because of excess hormones from birth control pills that have been flushed down the toilet. And so considering proper disposal, bringing it to your local, I'm thinking the one in Carver County, it's at the jail. You can go and dispose of your expired medications and things like that, and they will take care of it. They'll get it to the right place and make sure that it's disposed of properly. So that's the societal impacts on our drinking water sources. There's other natural things that can impact our water as well. As you know, there are viruses and bacteria that exist in nature. Sometimes they are harmless. There's all kinds of bacteria in our soils. There's bacteria in the water. They're decomposers, not necessarily a bad thing. However, there can be some that can, as we've seen with our beautiful COVID-19, we've experienced changes in some of these things. And now when we're exposing ourselves as our population continues to grow, we can expose ourselves to some of these viruses and bacteria. And if it ends up in our water systems, and then we distribute that water to all of our homes and our communities, that can have significant impacts. The radioactive materials, there's some naturally occurring harmful elements in our soils. I went fishing in South Dakota a couple of years ago, and I was pregnant with my first son, Carter, and my brother-in-law said, "Don't eat the fish." He said, "Just save it for afterwards." And it's because the waters have high levels of mercury. And so having different contaminants or elemental contaminants in our water systems, again, naturally occurring. It's not like somebody went and dumped a whole bunch of mercury into these areas. It's just naturally occurring in the soils and the sediments, and that can get into our water system. So again, not necessarily because of human activity, they just exist. But it's important for us to be aware of it. And then you may have heard of the term eutrophication. That's the picture that's on the bottom. So natural eutrophication is basically just the natural decaying process, the decomposition of things like algae. So you've probably noticed before there are greenish, kind of scummy looking ponds and they kind of have a gross smell to them. That is due to eutrophication. So we have algae that accumulates and then those algae die and they kind of sink down to the bottom of the pond and it turns it into this really kind of mucky sediment at the bottom of the pond. That process is very natural, but when we add nitrates from fertilizers, that speeds up the process, and we call that cultural eutrophication. And so this could be a natural thing, just the breakdown of organic material like leaf litter and algae, but there can also be the accelerated version where the human interference occurs. And then we get into the treatment and the distribution, and this is where I'll talk a little bit about Flint, Michigan. So we need to make sure that our infrastructure, the pipes, the buildings, that all of that is well maintained. You may have seen in your neighborhoods before that the fire department or even the public works people will come and flush water out of the fire hydrants in your neighborhood. They'll just let the water run for a little while. That's to help make sure that the water is not sitting stagnant in these pipes for too long. So they go and they flush them out. They even do that in our classrooms. They'll come through and run the eye wash stations in the back of our lab to make sure that the water is not stagnant in the pipes because water can help break down and corrode with some of the chemicals inside of the pipes. And so running the water systems and maintaining those water pipes is really, really important. Sometimes also the way that we treat the water, if we don't have certain additives, that's when it can lead to chemical reactions inside of the pipe. So this is where I'll talk a little bit about Flint, Michigan and the water crisis of Flint, Michigan. You've probably heard of the lead contaminants and lead poisoning that took place in the Flint, Michigan changing of their water source. So originally, Flint, Michigan was getting their water from Lake Huron and the Detroit River. And then I don't know all of the specific details, but they had to switch their water source. They were no longer able to get their water from Lake Huron, which was relatively clean, and the Detroit River, also relatively clean. So instead, they had to then switch their water source, where they were getting their water from, to the Flint River. And the Flint River had higher contaminants. There was a certain chemical, I don't recall the name of it, but a certain chemical that would interact with water. And one of the byproducts of that reaction was lead. And the lead is invisible in the water. You can't see the lead, but it was also corroding the iron in those pipes as well. And so that's when people started to notice the change in their water and it started to look like the rusted water and the orange water. But by that time, they had already been exposed to such high levels of lead for so long that it became a public health crisis. And so I believe now they have gone through, or part of the remedy to that problem that they had was that they had to go through and replace all of their pipes. And unfortunately, it's an economic issue as well because the economy of Flint, Michigan, they didn't have, you can't necessarily tax or increase taxes. You're not necessarily going to be voted in to increase the taxes in order to help support changing out all of the pipes underground. You think about all of the work that has to go into that. You have to dig up the roads. You have to find the pipes. You have to replace the pipes, shut off the water, change the water, replace the pipes, and then rebuild the roads. And you have to do that for your entire community. And that's just not something that was easily done. They had to have the financing for it. And I believe that there was federal aid to go into that project as well. But I know that the people who live in Flint, Michigan, it was a huge injustice to them. They weren't necessarily able to do anything about it, and they couldn't change the water source. So a big deal. Feel free to look into that a little bit more, but that's kind of the basic details of what happened there. point for all of you to walk away with is we need to make sure that we're encouraging our communities to support the maintenance of the infrastructure, maintenance of the pipes that are bringing that water into your homes, making sure that you know what additives are going into it. I think that was part of the thing with Flint, Michigan as well, is they didn't include the additive to help prevent the corrosion, which was a problem there as well. So I don't know if it was an oversight or intentionally or handling of the water, but that's an important part as well. Remedies to the threat. So what can we do to help protect our water? There are source water protection rules and regulations. We need to try and minimize how much of our water, our surface water, is polluted. So minimizing that pollution. We can do that in lots of different ways. But if you can minimize the pollution in your surface water, then your underground water, where the surface water kind of percolates or trickles through the soil and replenishes the water underground. So protecting those areas, making sure that they're not getting polluted is a really important part of that. Maintaining and supporting the water treatment facilities. If we think globally, there's plenty of places around the world that don't have the ability to create water treatment facilities. The developing countries certainly aren't going to have 4 water treatment facilities in their communities, right? That's something that we have here in a developed nation, but it's not accessible to everybody. So what we can do here is help to support that through donations or funding, and helping those developing countries at least have access to the clean water by helping them support or develop those infrastructures. Maintaining our water mains, those are the pipes, the infrastructure is the water main pipes. Maintaining them, supporting our local officials who can help make sure that those are being maintained. That's an important part. Again, we know that it's going to cost money, and again, as a public works thing, it's a taxpayer benefit, but we all benefit by having those clean. And then communicating and educating people about water. So I like to teach this unit because I think a lot of us just take it for granted. You know, you turn the faucet on, oh, great, I have water, turn it off. Now we're done. We don't have to think about it, but it's important for us to think about, where did our water come from? Okay, where does it go when it goes down the drain? And what's being done to make sure that I have safe water when I turn on my tap? I've included here a website. You can pause this to copy it down, or I can try to link it into this quiz as well. But I encourage you to go to this website. It's your Edina Public Works Division, the Utilities Division, and the chairman, or the guy who runs it all, I actually met him at a water class that I took in Eden Prairie. He was there to share information with me, and he said that he loves to work with students. So again, if you have an opportunity to reach out to the Public Works and go take a tour of the facility, tell him you're a student or you were a student at Edina High School and you just want to learn more. I think he would love to have students come and learn more about the water system. So take a look at this if you wish. I had one more thing I was going to try to link on there. I think I have it at the end of the PowerPoint. Another way to increase water supply, some of you were asking about desalination. So in these areas, like California, for example, where they're part of a developed nation, they have the infrastructure. The problem is they just don't have a lot of water, but they're surrounded, or at least they're on the coast, so they have access to water, but it's not the right type of water. It's salt water. So salty water is salinated, okay, saline, salty. So these desalination plants are going to basically take seawater, salt water, and turn it into drinking fresh water, removing salt from the seawater. And they can do this through a couple different ways, reverse osmosis or distillation. So basically you can push the salty water through a filter and hope that you're filtering out all of the salt, or you can evaporate the water and then try to collect that in a separate container, separate system than the salt itself and anything else that would be left behind. This article the desalination is booming as cities run out of water. I'll link this in at the end as well, just in case you're interested in learning more about it. But California has, I believe it's 11 desalination plants, and it's a viable way for us to give more people access to fresh water, especially when they're experiencing drought. The problems that are associated with desalination plants are that they're really expensive to run. It takes a lot of energy in order to remove the salt from the seawater. And then there's also environmental impacts. So when you set up this plant to pump water out of the ocean, you have to think about all the wildlife, like the fish, the corals, the algae, all of those small organisms that you're taking water away from. So you're pumping the water in. We have to somehow filter out the fish so that the fish don't get sucked up. And so there's kind of the animal rights and the ecosystem balance. We don't want to shift that balance too much. And then the other question, or the other kind of big factor, is what do you do with all the salt? People are like, you can throw it back into the ocean, but then that shifts that balance again. Now you're adding even more salt to a salty environment, shifting that balance, which could potentially then throw off some of the organisms that live there. And so it's definitely a viable solution. It's a working solution for providing more fresh water to those in need, but it does come with some costs. Other ways, this is what I mentioned earlier, there's programs that you can donate to help bring water to communities in the developing countries that simply don't have access. So you can see in that picture there, it says for 1 billion people, safe water is scarce. And I personally wouldn't want to be drinking water from this kind of cloudy looking pond. But unfortunately, there's many people in the world that is their drinking water. And so we, again, take it for granted. I go to my kitchen sink, I turn the water on, I turn it off, and I'm happy as a clam. But that's not how easy it is for other people around the world. And so considering these other people and making donations, I had a glass donation a few years ago. And with this particular project, they send you emails to let you know the progress of the well that you've helped develop. So that's kind of a fun thing. You could do that with your family and her friends. If you're looking for something to do, or any other kind of project that would be similar to this. All right, so I think I answered several of your questions. I didn't get to everybody's questions from the quiz today, but I think we'll go ahead and stop there. Hope you learned something new, and we'll check in again tomorrow. All right, have a good rest of your day.